Hi everybody. So today we will revise the function in vertex form, which are a part of quadratic functions. So the vertex form have this equation form, which is y is equal to a times x minus p squared plus q, and this shows us that the graph has a parabolic form, shape, and there is a vertex, which is where the function changed the direction. So whenever the function changed the direction, that means that point is the vertex point. So all these points are the vertex points. So, and it also has a symmetry with x is equal to p. So the point p of the vertex actually show us the symmetric axis. So you come to your p point and you just draw a vertical line that pass through that point, and it will give you the symmetric point, the symmetric line of that function. Okay, whenever you have this form, that means there is a translation, horizontal translation and vertical translation. So let's go over all this unknown one by one. So for A, it shows you is the graph widely open or shortly open. If the graph is widely open, that means your A is between 0 and 1. It is less than 1, and it should be greater than 0. So between 0 and 1. If the graph, the original graph, is stretched, like it's become smaller, less wider, that means your A is greater than 1. If your A is positive, that means your parabola is upward, is going from one side to other side, but it's looking upward. If your A is negative, that means your parabola is downward. Okay, this is the job of our A. For P, actually it's not just the P, it's minus P. It should be minus P. The minus P shows you that the graph was horizontally shifted, not vertically, horizontally shifted. Okay, if you have here minus P, that means your parabola was shifted right side with a P unit. Okay, if you have here plus P, that means your parabola was shifted left side with a P unit. For the Q is the vertical translation. If you have plus P, that means your parabola was shifted upward by Q unit. If you have minus Q, that means your parabola was shifted downward with a Q unit. Good. So now let us see exactly some example. Like, we have a function that was just, the original one is just x squared, which is the blue one here. Okay, and when we want, if we want to shift this function to the right side, so I should just have my P here inside the parentheses with x. For example, I want to shift my x squared 1 unit to the right side, so I should have my x changed to be x minus 1 everything squared. That's the only thing I need to change. If I want to shift my parabola to the left side with 2 units, I should change my x to x minus plus 2 because I'm going to left side. So left side it should be plus 2 square. Okay, and same thing if we are shifting 3 units left side, it's plus 3. If I want to shift my same parabola but upward, so I should just have my x square plus the value I want to shift. For example, I want to shift my parabola 2 units upward. I should have x square plus 2. It's not inside the x square, it's outside, should be outside. If I want to shift my parabola like left downside 1 unit, I should put my x square minus 1 unit down, so it will go down. If I want to shift horizontally and vertically my parabola, I should change both of them. So I should have my x minus my p inside the bracket plus my q outside the bracket. For example, for this parabola, I am shifting my original one to 3 unit right side, horizontally right side, and 2 units upward because it's plus 1. And because I have my a is negative, so my parabola should look down. Okay, and because also my a is greater than 1, so my parabola will be shifted, will be stretched a little bit down. So my parabola will be smaller. It's not will be wide as the first one, so it will go inside a little bit. Perfect. I hope you understand this stuff. Okay, this is a real example. So exactly as we saw before, this is just to repeat. I have my a is positive. That means my parabola, the original one, which is y, is equal to x squared. Now it should look up, down. It should look up because my a is positive, and also my a is 2. That means my parabola should look smaller than the x squared, the original one. Now I have plus 1 here, so that means I shift my parabola left side 1 unit. Okay, I shift my parabola left side 1 unit, and because I have minus 3, I shift my parabola downside 3 units, and this is exactly what you have here. 1 unit to the left, which is minus 1, and 3 units downside, which is minus 3, and stretch it a little bit, like make it smaller than the original one. This is the original one, and I will get my graph, my equation graph. Okay, now for the other form of a parabolic function, or a quadratic function, the other form is the standard form. So we just saw the vertex form, and it is called the vertex form because you can directly see your vertex point from the equation. So the vertex form was like this: x minus p plus q. So these 2 points show me the vertex. So the vertex is pq. I can see them directly there. That's why it is called the vertex form. However, for the standard form, you cannot see your vertex there directly. No, you cannot. You know it is parabolic form. It has a parabolic shape. You know your a, if it's positive, it will be looking up. If it's smaller, if it's negative, it will be looking down. If it's between 0 and 1, your parabola will be widely open. If it's your a is greater than 1, your parabola will be like smaller. However, to find you need to find your p and q so you can see your vertex, and that's we will see in the next slide. So this is just same thing from the same equation, from this equation that have this form, the standard form ax squared plus bx plus c. You can get the same, all the information of parabolic function, which are the vertex, the x-intercept, the is it up or down, is it like wide or no. So now let's us see how we can find the vertex. So to find the vertex, you need to know these equations. So this is the standard form and this is the vertex form. So your P, if you want to go from standard form to vertex form, so you can know where is your vertex, you should calculate your P. Your P is minus B over 2A over 2A. And your Q will be your C minus A times your Q that you find square. Okay, got it? Perfect. So let's see some examples. So for example, we have here, for example, let's see this, for example, just example, let's see this equation. So this is the regular one, x squared, all know it. This is x squared minus 2x, but you cannot see the vertex there. Same thing here, minus x squared plus 2x plus 8. It is same thing as the, but you cannot see the vertex there. So to see the vertex or to know your vertex, you need to calculate your P. So for example, for this y, we start with our B and C. So what is your A here? So my A is minus 1, my B is 2, my C is 8. So this is the first thing I should write. So my P is minus B over 2A, which is minus 2, because my B is here, so which is minus 2 over 2 times minus 1. This is 1. Okay, I just find my P. Now let me find my Q. My Q is C. From this equation, your Q is C, which is, I have it here, which is 8 minus A, which is minus 1, times P squared. My P squared is 1 square. Okay, this is my Q. So my Q is equal to 8 minus 1 is 1 times 1 is 1, so it's plus 1. It is 9. So now my vertex point are 1 and are P and Q, so they are 1 and 9. And I know from my previous explanation that the axis of symmetry will be at P. So my P is there, so I will have my symmetry at 1 here. So 1 is my axis of symmetry. Good, symmetry axis. So now you know, so the vertex point is this. The vertex point is, you go 1, find 1, it's 1 and 9. So 1 and you go up 9. So this is my vertex. So my vertex is 1, 9. This is my vertex. Okay. From there, I can actually write my vertex form equation. So my vertex form equation will be, I know it's y a times x minus p plus q. So my vertex form is a is minus 1, so minus 1 times x minus p minus 1 plus q, which is 9, plus 9. Good. So now I see from this equation that my parabola was shifted right side 1 unit and upside 9 units, and it was reflected downsideward because my A is negative. Okay, and this is exactly what you can see from here. It is same as this one, shifted the right side 1 unit, upside 9 unit, and flip it downside because my A is negative. Perfect. You can do the same thing for all of them. Same thing. Here you have your C is 0, and you apply the same formula and the same knowledge just you learn just right now. Okay, so this is one real life example. So if I have this is my equation, so this is plus 0. So the first thing I need to find is my P. So my P, so my A, so let me write my A. My A is what? Is minus 1. This is A. Okay, my B is 50, my C is 0. Now I can write my P. So my P is equal minus B over 2A, which is minus 50 over 2A, which is 2 times minus 1, which is 50 over 2, which is 25. So this is my P. My Q is C, which is 0, minus A, which is minus 1, times P squared, 25 squared. Okay, 0 minus 1 times minus 1, which is plus. So 25 squared is 625. 625. So my Q is 625. So my vertex point are 25, 625. And I can come to my graph, and I can also write my equation, my vertex form equation, which is y is equal to a times x minus p plus q, which is my A is minus 1 times x minus p is 25 plus q, my q is 625. So what we have here, we have a parabolic, no, this is square, sorry. Yeah, also the first one is square. If I did not find it, yeah, sure, sorry, yeah, sorry, this is square. This is square. Because the standard form is square. Your vertex form is square. You can see it, square. Okay. So where is it? Yeah, here. So from here I can see that my parabola, which was originally like this, okay, normal x square, regular one, I have to shift it right side 25 units. So I will shift it, this is my parabola x square. I will shift it right side 25 units, okay, and up side 25 units. So I will take it 25 units right, okay, and up 625, and I will draw it. I will flip it because my A is negative. And this is exactly what you can see here. Right side 25 units, which is here 25, and upward 625, because the original one was like this. When I just flip it and move it right side, and I have to take it upward 625 units. Perfect. Okay, let's us do some exercises related to quadratic function. So the first question, use transformation to explain how the graph of each equation compared to the original one. Okay, It's just asking us to tell is there is horizontal shift, vertical shift, whatever is there, we can talk about it. So for the first one, so our a is 1. So the graph, the original graph x square, was not deformed by any value, negative or positive or less, between 0 and 1. So our our a is just 1, so we are having the same graph. However, we have our minus p, so there is left horizontal leftward shift of the original function, and there is also minus q, so that means there is a downward vertical shift of the function. So the function, this function, will have the same shape as the original one, fx is equal to x square, since a is equal to 1, and because p is equal minus 6 and q is equal minus 14, this represents a horizontal translation of 6 units to the left side and a vertical translation of 14 units downward relative to the graph x square. So you can also know, you can detect the vertex point is minus 6 minus 14. This is the vertex, and we have a symmetry axis on x is equal to minus 6, and it is a parabola upward because a is 1, which is positive, and it has a minimum value at minus 14. The domain the domain is all value in R, so x is in R, and the range is the minimum value upward, so from y will be greater or equal to minus 14. And for the same thing, you can do the second one. And basically, if you understand the first one, other one will be easy to do. For the second question, it is asking us to sketch each graph, each quadratic function using transformation, identify the vertex, the x-axis, x of symmetry, the range, the domain, the minimum value, and the y-intercept. Okay, perfect. So we can say, or we can write for the equation, this one, our a is equal to 1. No, it's equal to 2. Our p is minus 1. Our q is minus 8. So to sketch the graph fx, y is equal to x plus 1, everything squared minus 8. We need to transform the original one, which is y is equal to x squared, by multiplying all y value by 2, okay, and translating it to the right, to the left side, because it's positive, so it should be left side. We will translate it 1 unit to the left side and 8 units downward. Perfect. The vertex are like, the vertex is p and q, so we have minus 1 and minus 8. This is the vertex. The x symmetry is the symmetry axis will be x is equal to our p, which is minus 1. Let me draw a simple example here. So this is my x. No, this is not good. So this is my x, and this is my y. So we are talking about the x symmetry at -1. So I will go -1. This is -1. So this is my symmetry axis. Okay, so my function will be symmetric around this. So what we will draw it correctly. So the vertex is in -1. We have the vertex -1, -8, which will be -1 is here, and oh no, -1 is here. We should just go -8. -1, 2, 3, 4, 5, 6, 7, 8. So this is my 8. So this is my vertex point. Okay, so this is my V. For the x-intercept and y-intercept, we just need to solve this equation. Let me remove this. So we got this. So for the x-intercept, you need to solve this is equal to 0. So whatever we will do, so 2 times x minus 1 square minus 8 is equal to 0. This means that 2 times x minus 1 square minus 4 is equal to 0. And because 2 never equals 0, so we will remove that. That means x minus 1 square minus 2 square is equal to 0. This is same as x minus 1. This is a square minus b square, which is a minus b times a plus b. We just, this is our a, this is our b, so this is our a, this is our b. So which will give us x minus 1 minus 2 times x minus 1 plus 2. This is x minus 3 times x plus 1. So the x-axis, this is equal to 0. So the x-intercepts are x equal 3 and x is equal to minus 1. This is the x-intercept. So we will go to our graph. So x is equal to minus 3. Is x is equal to, no, this is plus. Yeah. So we will go to our graph and draw our x is equal to minus 3, so this is minus 1, minus 2, minus 3, so this is minus 3, and x is equal to 1. This is 0, this is 1. So we have these two intercepts. So my graph will go like this. For the y-intercept, the y-intercept is how we will find our intercept. We just give this a value of 0. So 2 times 0 plus 1, which is 3. So we have 2 times 1 minus 8, which is minus 6. So the y-intercept should be minus 6. So my graph should touch the y-axis in minus 6. Minus 1, minus 2, oh no. Minus 1, minus 2, minus 3, minus 4, minus 5, and 6. So my graph should touch this. So it will go this, and the formula 1, same thing here. So this is our fx is equal to 2 times x square plus 1 minus 8. Good. So same thing for b, you do the same thing. For b you have 0.5, that means your minus 0.5. That means your graph will be looking downward. Graph will be looking downward, and it will be enlarged, not like smaller. It will be enlarged, and we have vertical. We have horizontal shift to the right, two units to the right, and we have 2 units to the top. So the vertex will be 2, 2. So you come to your graph, and 2, 2, 1, 2, 1, 2. So this is the vertex. This is where your parabola will change the direction. So this is 2, 2. Okay, good. So the only thing, the y-intercept, the x-intercept, same thing. You solve this equal to 0, and one of them is 0, then the other one is 4. Okay, good. For question 3, is it possible to determine the number of x-intercepts in each case without graphing? Explain why. Yes, we can do that, because if we look here, our A, so let me take another color. So my A is -3, so my graph is looking downward. My P is 5, so there is a horizontal shift to the right side, 5 units. So if this was the original one, so the next one will go to 5 there. Okay, and it is taken up 20 units up. So this will be my last one. So this is 5, okay, and this is 20. So my vertex will be here. So you can see it will touch the x-axis into different places. So yes, this one will be touching the x-axis 2 times. A parabola with the domain array, the domain R, and the number, the range is y is greater than 0. So this show me that. No, I want to raise this. So this show me that my y-intercept is 0. So I don't care is it going up or going down, okay? But it touched the x-axis is in just 1 point, because my range is starting. Oh my God! Because my range is starting from 0 upward or downward. And if I look to my range, from whatever they are telling me, that my range is above 1. That means I will keep this one and I will cancel this one. Okay, so it is touching the x-axis in 1 point. So 1 point touching. For the number C, y is 9. This is same as 3x squared plus 9. So there is no horizontal shift, but there is a vertical shift of my graph. So my graph is same as x squared, but just go up 9. So the vertex is 0, 0, 9. So this graph will never touch the x-axis because it is upward, okay, and the vertex, the minimum point is 0, 9. So this will never touch the x-axis. Good. So for the question 4, determine a quadratic function. Determine a quadratic function for each of the set of characteristics. So they are giving us points. So we have the vertex as 0, 0, and we have points. So the first thing I should write here is my P is equal to what? Because the vertex are the point of P and Q. So my P is 0 and my Q is 0. That means my equation will be y is equal to a times x squared, because my p is 0 and my q is 0. So from here I can detect, I can find a by replacing x by this value and y by this value. Okay, I will just write this as minus 150, which is my y, is equal to a times my x, which is 20 squared. Okay, and this tell me that a is equal to minus 150 over 20 squared, which is minus 150 over 400. Okay, so my if you reduce this, you can reduce this, I think you will get minus 3 over 8 or something like that. Okay, so my final equation is y is equal to minus 3 over 8 x squared. Okay, this is my final equation. Same thing for B, same thing for question B. Same thing, you have your P is 8, your Q is 0, so the question will be, the equation will be y is equal to a times x minus 8 minus 8 square plus 0, because my q is 0. And you can just do the same thing, replace x by this value 2 and y by this value, and solve for a. It is very, very straightforward. So let me see this point. Same thing. Here we have minimum value is minimum value is 12 at x is equal to minus 4 for this question. I'm talking about this question. This one. Minimum value is 12 at x is equal to minus 4, and y-intercept is 60. So from here you can say that your equation is y is equal to a times x minus plus 4, because it's minus 4, so x plus 4 square plus 12. So this is your P, this is your Q, because the minimum value is the P, always minimum value is P, and this is Q, and the at x is equal to minus 4. This is show me that my P and Q are minus 4 and 12. And you have the y-intercept, which is 60, so you can replace x. So you can replace x by 0 and y by 60, because they are giving us the y-intercept is 60 to find a. And from there you will get 60 is equal to a times 0 plus, why it's come this 4, you know, this is 4 minus 4 minus plus 4 square plus 12, so it will give you 48 is equal, so just is equal to 16a, that means a is equal to 3. And you from there you can write your final equation as your greg is y is equal to 3 times x plus 4 square plus 12. Okay, good. So we did A, we did B, we did C. You can do D, it's same thing, it's just easy stuff. So for the question, this question number 5, we write a quadratic function in vertex form. So they need us to write y is equal to a x plus minus q minus p plus q. So this is the vertex 4. So to do that, we need our p and we need our q and we need our a. So from here, we said that the vertex is always the p and q. So my vertex and my vertex is here. So this is what? This is minus 3 and minus 6. So this is p and this is q. P, q. I have my p, my q. Okay? And we can get also, we have also, so start by there and write the equation is y is equal to a times x minus 3, which is plus 3, square minus 6. Okay, this is the first equation. We need, from here we need a point. So to find our a, we need a point. For example, we'll choose this point. This point, name it a, and we have x is 1 and y is minus 2. And we will just substitute this x to here and this y to here. And we will find our a. So our y is minus 2 is equal to a times x, which is 1 plus 3 square minus 6. So this will give me so minus plus 6, which will be 4, is equal to 16a. So that means a is equal 1 over 4. Then the final answer is y is equal 1 over 4, which actually makes sense because my parabola is looking upward and my a is positive, times x plus 3 square minus 6, which is our final answer. You can do the same thing for this one, same stuff, same thing. You have your vertex v here, which is x is 1 and y is 5. And you just write the equation, your equation as y is equal to a times x minus 1 square plus 5. You substitute, you choose a point. For example, this one is 0, 3, and you substitute the value here, x here and y here, and you solve for a and you write your final answer. Okay, this question is important to do because I read it before, I find it interesting, so we needed to do it. So they are telling us that this solar system have a parabolic shape, okay, and what they want us to determine the quadratic function that represent the cross section shape of the mirror. Okay, they are actually asking us to find like what is the equation, so the vertex form of the equation. So my equation will, so let me draw first a graph for this. So my parabola is like this. My parabola is like this, okay, as you can see from the image is like this, okay. So what they are telling me, no, this is not good. Okay, let me draw a good line. Okay, I choose my parabola to touch the x and y axis to make my life easy. Oh no, to make everything easy for me, 0, 0. So my vertex, I choose it just to make my stuff easy. I choose my vertex as 0, 0. So what they are telling me, they are telling me that has a width of 180. So my width, the whole thing is from here up to here, is 180. How about half of it? Half of it will be from here to here, will be 90. Okay, and they are telling me that the depth of the parabola is 56. That means my parabola from the depth from here to here is 56. Okay, so this is my 90 and this is my 56. Perfect. So my equation will be as this, so which will be the form of y is equal to a times x minus p plus q. Okay, this is the general form of my vertex equation, but I know this is 0. I know this is 0 because I choose them to be 0. This is my choice. I don't need to complicate my life. So my equation can be written as y is equal to a times x squared. This is my equation. So now I need to find my a. My a, I can use a point, for example, this point. So 56 is equal to a times 90 squared, because my x is 90 from here to here and my y is 56. So my a is equal to 56 over let me put this in the calculator. Yeah, 8,100. So this is my a. So my final answer is y is equal 56 over. You can reduce this if you want, but the basic one equation is this. But you have a calculator, you can reduce it, I think, to 14 or 15, I don't know. Okay, same thing for the question number 7. It is exactly same thing. You just need to draw a parabola shape that is the distance between the towers is 56. The whole distance between the two towers is 274, and the height is the height will be so this is 130. No, this is your vertex will be at 137 and 22. So x will be 137, which is a half of this, and 22. Okay, good. Okay. So let me do exercise number. We did 7. I think we should do 9. 9 is good. Let me see 8. 8 also is good. So let's us do number 8 before we do 9. So number 8, they are telling us that a free jump from the ground, so it starts from the ground and it jumps somewhere like this to a height of 30. So it goes to a height of 30, and it's a height of 15. So 15, 30 centimeters horizontally from where it starts. Suppose the origin. Now they are telling us where is the origin. They did not give me the choice to choose the origin. So, and the same thing, determine the vertex, and that's all that information. So the first thing we need to do is to draw our function. So my x-axis will be like this. My axis will be this, like this. So because they are telling me, suppose the origin, so my origin here, 0, 0, my origin 0, 0 is the starting point. Function is where the actually the flay starts jumping. So I know it jump up to 30 centimeter. So this is 30, and it goes widely 15, 15, 15. So this is 15. So where is my symmetry axis? It will be at half of this, so it will be 7. So my jump will be like this, okay, because it jump and go back. So so the jump will be like this, okay. From here I can see this is 15, the widely went. So my equation will be like this: y is equal to a times x minus p plus q, okay. And my vertex, so this is the vertex. So the vertex is at what point? X is what? X is 7.5, which is a half of this, okay. And y is 30. Y is 30. So I have my p and my q. So I can just write my equation as a square. I always forget this square. Minus p, which is 7.5 square, plus 15. Okay, good. And because it's looking down, I know my a will be negative. So to solve this problem, I need to have 2 points. So let me choose, for example, this point. I will choose this point. Why not? 0, 0. So I will replace x with 0 and y with 0. So my equation will be 0 is equal to a times x minus 7.5 square plus 30, which is, I will put minus 30, minus 30 is equal to, so 7.5, this is like, my x is what? X is 0, so 30, I should put 0 here, so this is 0. Okay, let me remove this and put a 0. So this is 0 because I just substitute 0, 0, the point 0, 0. So this is a times 7.5 square, which is 56.25a. So my a is minus 30 over 56.25, which is minus 8 over 15. Okay, so my final equation will be y is equal minus 8 over 15 times x minus 7.5 square plus 30. So this will be my final answer. So let us do question number 9. Question 9 is telling us the coordinate of a vertex. For each graph, identify the vertex axis. Identify the vertex axis of symmetry. Okay. Maximum and minimum value, direction of opinion, domain and range. Okay, good, perfect. So the first thing I will start is the vertex. So where is the vertex? The vertex is at this point, and this point is what? Is x is 2 and y is 4, and basically my axis of symmetry will be this, is x equal to 2. So for the first one, the axis of symmetry, x is equal to 2. Okay, the graph has a maximum value at 4. So this is a maximum value because it just go down. Since the parabola is up and down. Okay, My A is negative. The domain is all value of R. You just grab this there, all R value. Anything on x-axis is in the domain. So the domain is equal to R. The range is, it start from 4 and go down. So Y will be less or equal to 4. This is the range. So the x-intercept, I can see it here, is 3. Okay? The x-intercept is, no, the y-intercept is 3. The x-intercept, I have 2, -2 and 6. Same thing, you can do the same thing for B. Very easy stuff. So let us do number 10. 10 is a little bit good as a practice question. Show why each function fit the definition of a quadratic function. So to do that, you just need to show this as a times x squared plus bx plus c, and you find the maximum power is 2, and you will say either yes, this is a parabolic form. So let's us do this first one. So 7 times, so y is equal to 7 times, don't know why this thing is a little bit not clear. Yeah, okay, 7 times, I will just expand this. I will expand this. So x squared plus 6x plus 9 minus 4, which is equal to 7x squared plus 42x plus 63 minus 4, which is equal to 7x squared plus 42x plus 22 minus 41. The question here, yeah, 41. Good, perfect. So it has the maximum power is 2, then it is a parabolic form. Very easy question. Okay. For the other one, you need to expand it, same thing, just this times this, this times this, this times this, this times this, and you will get one with x squared something. It shows you the parabolic form. So let's see question number 11. Where is 11? Yeah, this one. Sketch the graph of the function, this function. Identify the vertex, the x-axis. Okay, to do this, you need to get some value. It's very easy. So the first thing you need to do is find your P. Find your P, okay, your Q, your A. So from here, I know my A is -2. This is my A. Okay, my P for my equation is minus B over 2A. Okay, which is, you can see it from, I don't know if you have, yeah, I have it here. You can see it here. This is B. This is your B. So this is your P minus B over 2A, and Q is this. So I will just apply my equation. So minus B, which is my B. This is my B. Okay, this is my C. So my P is equal minus B, which is -3, over over 2A, which is -2 times 2, which is -4. So my P is 3 over 4, which is, I think, 0.75. Okay, so I have 0.75. My Q is C minus AP squared. Okay, let me remove A. Really now A. So this is A, this is B, this is C. So my Q is C minus AP square, which is C minus is 5 minus A minus 2 here 4 P square, which is 0.75 square. This will give us and minus times minus is plus, because minus A minus A, it's plus, so it will give us 4 times, let me do that in the calculator, so it gives me 6.125. So my Q is 6.125, my P is 25. So my vertex, the changing point is 0.75 and 6.125. Okay, I know now, because my A is negative, my parabola is looking down, the vertex is minus 0.75 and 6.125. This is my highest point. I need just to find the x-intercept. The x-intercept, I have to make this is equal to 0 to find my x-intercept. Okay, but the general form of your parabola is like this. So let me draw x, this is y. Okay, and I have my vertex is what, 0.5, 0.75, which is, for example, this is 1. For example, this is 1. So my 0.75 is little bit less than 1, which is here. And my 6 is here. This is 6. This is 0.75. Oh no, it's gone. Wow. Okay. So my parabola actually will be, and I will have a axis symmetry here. Okay. So my parabola, this is symmetry axis. So my parabola will be doing like this. Okay, and it will touch the x-axis somewhere here, and it will go there. Okay, this is the general form of my equation. So I can give x when x is equal to 0. Okay, 0, 0, 0. The y-intercept will be 5. So this will be 5. How I find this? I just can have x is equal to 0. So this is 0, this is 0. That means my y will be 5. So the y-intercept is 5. For the x-intercept, you solve this is equal to 0. So you put 2 minus 2x squared plus 3x plus 5 is equal to 0. You just find it as something times something equal to 0. And this will be x plus 1 times x minus 3 over 2, 2.5. Okay, so this will be 2.5, and this will be minus 1. Perfect. So let me go to the... Okay, so question 12. Very easy question, very easy question. It just you need to they are giving you the formula of the equation, the parabola, how it will look like. This is your P your P is 0 because I don't have anything here plus, and no, sorry, my this is plus C, so my P is minus B over 2A, and this is my A, this is A, and this is B, and C is equal to 0, and this is my C. So my P is equal to minus B over 2A, so minus B is minus 1 over 6 over 2A, 2 times this, which will be 0 0.064. Okay, so the vertex will be, I think this, if you think this will be, yeah, it will be minus here. This will be minus, so this is 25. So this is 25. So P is 25, and for your Q, same thing, you apply the equation. Q is C, like this equation, this one. C minus AP squared. So C minus AQ P squared, and you find your Q, which is 20. Okay, good. So now I have all the information that I need. So my equation will be Y. I will write it as, I have my vertex, so I have the vertex is 25, 20. Okay, and if I, the y-intercept is 0, because if I put this 0, this is 0, everything will be 0, so y will be 0. Okay, so the y-intercept is 0, and the x-intercept, I will put this, everything is equal to 0, so I will factor by d. That means my d1 intercept is 0, the other intercept is so d times d 1.6 minus 0.2d. That means the other d is 1.6 over 0.32, which is 50. So the x-intercept, the two x-intercepts, x is equal to 0, no, d equals 0, and d is equal to 50. So my parabola will be like, my drawing will be like this. So I will draw to x and y. So the vertex is 25, 25, 20. So maybe I will go 25. This is 20. This is 25. Okay, maybe this is 25, and this is 20. No, I don't know why this thing is. This is 20. Okay, so my vertex will be here, and because my A is negative, that means my parabola is looking down. So I know my, and there is a y-intercept at 0, and there is also x-intercept at 0. So my parabola go from there, go through 0, 0. So then my parabola is going to the 0, 0. Okay, the other x-intercept is 50. And I got everything, so I draw everything. So represent the function with the graphically. What is the maximum? I got it. The maximum value is 20, 25. How far downfall does the ball fit? Is 50 up to here. So see how far is 50, because max, what's this? So if I just find this 50 is here, so the ball will go from here to here. Okay, since for C, for D, what are the domain and range? Because we are not using the negative value, Okay, so the domain is from 0 up to 50. So x will be between 0 and 50. You are not using more than that. It's not a real number because it's a real life example. And the y intercept is from same thing. We are not dealing with this thing with negative value. So the y is from here to here. So from 0 to 20. So y is between 0 and 20. Good, perfect. Okay, let us do one example. We'll write function in vertex form. So we have the normal form and we will write it in the vertex form. To do that, we need to complete the square. So for the first one, I can write this as equal x, y is equal to x square minus 2 times 12x plus 12 square minus 12 square plus 10. Okay, what I'm doing here, I know my from my equation a minus b everything square is equal to a square minus 2ab plus b square. So I'm trying to make my equation look like this so I can immediately write it as this. Okay, this is the key solution to all this example. You just have to take your equation from this form, try to write it as this form, and from there go to this one. So let me remove this because this is very important to understand this. So for this one, for this equation, I have this. I have it in this form, okay? But this is my a square, okay, minus 2 times ab. I have my a here, but I don't have b. So I will bring up this 2. So I have to make up this 2 plus b squared. So to do that, I will write my equation as this. X square, which I have there, minus 2, which I need to bring, okay, because as I told you, a square plus 2ab plus b square, or minus, I have minus here, so I will use minus, square is equal to e minus b square. So if I write it at this form, I can go to this form. So minus 2 times 12x plus, so I need to have my b square. So I can see here, this is my b. So I will just write b square 12 square, and I should remove it again because I don't have it in my original equation, plus 10, which I have here. So this is equal to what? So this is equal to x square minus 212x plus 144, okay, minus 144 plus 10. So this is equal, because I have this as this form, I can switch it to this form. So this is equal to x minus 12 square, which is a minus b square, minus the rest, minus this. So minus, how much is there? Minus 134. Okay, so I got my equation in vertex form. So my a is 1. I can see my a is 1. Okay, my a is 1. My q, my p is 12. My q is 133 and 34. This is the same way you will do all of them, and it is very, very easy one.